Algebra 2, section 4-2, solving quadratic equations by graphing. So solving is where the graph crosses the x-axis. That's where the solution is. So we're trying to find where the graph crosses the x-axis. This is where y equals 0. This is called a 0. This is called a solution. This is called a root. Okay, here's an example. F of x equals x squared minus x minus 6. And so we are going to graph this and see where this crosses the x-axis. So our step 1 for graphing is find x equals negative b over 2a. We're going to try to find the vertex. We're going to find the x value of the vertex first. Negative b, so that's negative 1 over 2a, 2 times positive 1. So negative 1 is positive 1 over 2, which is, will give me x equals 1/2. Ooh, x equals 1/2. What a dumb example, Mr. V. Too bad. We're going to graph it anyways. So we're going to make some fairly large units here so that we can make sure we get that half correctly. I'm going to plug half back into the equation. F of 1/2 equals 1/2 squared minus 1/2 minus 6 gross. All right. 1/2 squared is 1 squared over 2 squared, so that's 1/4. Minus 1/2. Now I'm going to quick change this 1/2 to, well, we'll do that next time. Okay, minus 6. 1/4. In order to combine these terms, I've got to change these to have the same denominator. So 1/2 with the denominator 4 is going to be 2/4. Minus 6. 1/4 minus 2/4 is 1/4 minus 6 equals 1/4 minus 6 is negative 5 3/4. But 1/4 minus 2/4 is negative 1/4, not just positive 1/4. So we end up with negative 6 1/4. So my vertex is 1/2 negative 6 1/4 gross. Okay. 1, 2, 3, 4, 5, 6, 7. We need a couple more lines there on my coordinate plane. Let's plot the vertex. So here's 1/2 for x. So that's my axis of symmetry. X equals 1/2. It's my axis of symmetry. Now negative 6 1/4. 1, 2, 3, 4, 5, 6 1/4 is like right there. So there is my vertex. Now I have to decide, is this going to go up or down? And this is going to open up so I can write my vertex here without being scared of it getting in the way. There's my vertex. Let's plot some points. Now our vertex is ugly. 1/2 and negative 6 1/2. But we don't have to choose ugly points to plug in here. Let's plug in 0 and negative 1 and 1 and 2. Let's plug in good numbers. All right, so 0, when we plug in 0, we get negative 6. When we plug in 1, we're going to get negative 6 as well. When we plug in 2, we're going to get 4 minus 2, which is 2 minus 6 is negative 4. And if we plug in negative 1, we're going to get negative 4 as well. All right, let's start plotting this guy. So 1, negative 6. Let's 0, negative 6, and 1, negative 6. 0, negative 6 is right here. 1 and negative 6 would be right there. 2 and negative 4. 1, 2, and negative 4. 1, 2, 3, 4. There we go. And then we've got negative 1 and negative 4. That'll be right there. Okay, so my graph is going to look something like this. I'm not going to do it too dark because I'm not sure where this crosses the line yet. So I think I need to plug in some more points to see where this is going. Let's plug in negative 2, and let's plug in 3 and see if we can find where that crosses the x-axis. So if I plug in negative 2, negative 2 times negative 2 is going to give me positive 4, minus the negative 2, so that'll be plus 2. 4 plus 2 is 6, minus 6 is 0. That's good. And then we'll plug in 3 just to make sure. 9 minus 3 is 6, minus 6 is 0. So we know when y equals 0 that I have a root or a solution or a 0 at that point. So at negative 2, boom, I have a point, and at 3, 0, I have a point. Here's where my graph goes through, just like that. So these are my solutions here. And so let's write our solution out. X equals negative 2 and positive 3. I have solved by graphing this parabola. Let's do a u-try, why not? X squared minus 3x minus 4 equals 0. So we can go ahead and have you graph this guy. And we're just going to graph it as if it was f of x equals x squared minus 3x minus 4. So we're going to find where this crosses the x-axis. Go ahead and pause and get to work. Let's see how you did. All right, x equals negative b over 2a. So negative b is here, negative 3. So x equals negative 3 over 2a, 2 times 1. Negative 3 is, oh gosh, another gross one. So I've got positive 3 over 2, which is 1/2. So my vertex is going to be 1/2 something. Ew, goodness. All right. So 3/2, I'm going to plug 3/2 back into here. I'm just going to leave it as 3/2 when I plug it back in because it's a little bit easier to do some of these computations. So 3/2 squared minus 3 times 3/2 minus 4. So I'll say f of 3 over 2. We'll say that. I've got 9/4 minus 9/2 minus 4. So I've got to change this. I got to multiply what I do to the bottom, I do to the top. So I got to multiply by 2 to get a common denominator. 9 over 4 minus 18 over 4 minus 4. So 9 minus 4, or 9 minus 18 is negative 9. So I've got negative 9/4 minus 4. 9/4 is 2 1/4. So negative 2 1/4 minus 4 is going to get me negative 6 1/4. That's the y value of my vertex. And so if I were to graph this, let's see if I can do it fairly quickly here. So 1.5 is my axis of symmetry. X equals 1.5 is my axis of symmetry. And then I go down 1, 2, 3, 4, 5, 6.25. There is my vertex, 1.5, -6 and 1/4. And then I'm going to plug in some values. 1 and 1/2, -6 and 1/4. So I'm going to plug in 1 and 0, and I'm also going to plug in 2 and 3 and see where that gets me. If I plug in 0, I get -4. So right away I know that -4 is not going to get me where I want to be here. When x is 0, y is -4. 1, 2, 3, 4. And so that means when x is 3, y is -4 as well. 1, 2, 3, 4. So my parabola is going to look something like this. And so I'm not even going to look at 1 or 2 because that's going to be -5 or -6 or something like that. I want it to be 0. So let's try -1 and 4 and see what that gets us. So let's try -1 in here. -1 times 1 is +1, minus 3 times -1, that'll be +3. 1 plus 3 is 4, 4 minus 4 is 0. All right, so this one gets me 0. If I plug 4 in there, I'm going to get 0 as well. So -1, 0 is a point of where we cross the x-axis, and also 1, 2, 3, 4, 0 is the point where we cross the x-axis. There's my parabola, and my solution is x equals -1 and 4. Now you may remember from algebra that I can say, what do I multiply together to get -4 and add together to get -3? It would be x minus, let's see, multiply to get -4, add to get -3. So x minus 4, x plus 1. And if you set that equal to 0, each of these, then you would get -1 and +4. So that's another trick. Okay. Why didn't you show me that earlier, Mr. V? Because I want you to practice graphing. Number of solutions. If I have a graph that looks like this, here's my coordinate plane, and I could have a parabola that looks like this, that doesn't cross the x-axis at all, so no solution. I could also have a graph that comes down like this and just bing, touches the x-axis and turns back around. So it only hits the axis at one spot. So this is one solution. And at this spot right here, this is the vertex of this parabola, and it's going to be x, and my y value is going to be 0. So my x will be whatever this is, -5 or whatever, and then my y value is going to be 0 at the vertex. And last is the one that we've already looked at, and that's when you've got two solutions and the parabola crosses the axis in two spots, two solutions. All right, we've got one more thing to look at, and it is estimating roots. Estimate roots. Sometimes you get an equation like this, x squared plus, minus 6x plus 4 equals 0. And we don't know where this crosses the x-axis, and if we were to plot this thing, we might not be able to find it. So let's fx and f of x. Let's find the vertex first. X equals negative b over 2a. So negative 6 over 2a, which is 2 times 1. So negative 6 is positive 6 divided by 2. X equals 3 is my vertex, or my axis of symmetry. 1, 2, 3. There's my axis of symmetry. Now, when x is 3, if I plug 3 back in here, I've got 9 minus 18, which is negative 9 plus 4. Negative 9 plus 4 is negative 5. So there's my vertex. 1, 2, 3, 4, 5. 3, negative 5. And I know, since my a value is positive, that this parabola is going to go up, something like this. Now, I need to estimate where that's going to happen. So let's see, we're going to need to plug in several numbers here. We're going to plug in 2, 1, and 0, and 4, 5, and 6. When we plug in 0, we get positive 4. Okay, so if we plug in 0, we get positive 4, which is up here somewhere, right? And so if we were to plug in 6, we'd also get positive 4. So that'd be way up here. 4, 3, 4, 5, 6, positive 4, up here. Okay. So we know that between the vertex and 0, it's going to cross somewhere in here. Also, between the vertex and 6, it's going to cross somewhere in here. Let's find those spots. So let's find where it happens. If we plug in, let's plug in 2. We plug in 2, we get 4 minus 12. 4 minus 12 plus 4. So 4 minus 12 is negative 8 plus 4. So negative 8 plus 4 is negative 4. If we plug in 4, we're also going to get negative 4. Let's plug in 1. 1 minus 6 is negative 5, plus 4 is negative 1. Negative 1, and if I plug in 5, I'm going to get negative 1 as well. So let's look at these points. Look right here where it goes from positive to negative. Stays negative, stays negative, stays negative. Oh, here's another one, positive to negative or negative to positive. That means between these 2 points, between 5, negative 1, and 6, positive 4, the graph crosses the x-axis. So somewhere right here between 0 and 1, I've got my line is going to cross the x-axis, or my parabola. Same here between 5 and 6. 5 and 6, it's going to cross somewhere in there. So I'm going to estimate that the graph is going to, here, it's going to cross the x-axis between 0 and 1, and it's also going to cross the graph between negative 1 and, oops, sorry, not negative 1, sorry, 5 and 6, positive 5 and positive 6. So this would be your answer for this kind of a question. If you're going to estimate the roots, what you're just doing is finding the x values that straddle where the parabola crosses the x-axis. So between 0 and 1, between 5 and 6. And that is the end of 4-2.